Alright, hello everyone. So this is the first lesson in the video series for algebra and competition math. And if you guys don't know already, there will also be a problem set and a video where we solve some example problems for the topic that accompanies every video lesson, including the first one, which is this one. So for this series, I also assume that you have some basic knowledge in algebra, maybe up to grade 9 or grade 10 high school math. But if not, you can still follow this lesson, although you might just have to do some extra research to grasp some preliminary information. So let's begin by looking at polynomials. So a polynomial p of x can be written in this form. And what this means, right, if we want to look at each term separately, so this is like a term, and this is also a term. And the a thing here represents the coefficient. So the coefficient ai times xi. So the power of the variable, which is x, is the subscript of a, which just denotes the coefficient. So if we look at the leftmost term over here, the power of x is n, and since this is the highest power of x in this entire polynomial, this is called the degree. So the degree of p of x is n, and the coefficient of the highest power variable is called the leading coefficient. Alright, so now we need to learn something called roots. So a root a root slash solution a root, let's call it R. A root or solution R of p of x satisfies so that means that if you replace each of these x's with R and you evaluate the whole thing, it's going to equal 0. All right, so another thing that you guys need to know is multiplicity. So essentially, if you think about it like this, right? Let's say you have a polynomial p of x is equal to x minus 1, x minus 1, x minus 1. And you can multiply this out and you'll get this form, right? But this, if we keep it in this form, this gives you what the roots are. Because if you substitute x equals 1, this entire thing is going to be equal 0. So that means we know that x equals 1 is a root. But since it's factored 3 times, there's 3 x minus 1s. That means we would say that the root, which is 1, so r equals 1, has multiplicity 3 in this case, because in its factored form, it has 3 x minus 1 terms. So we could just write this as x minus 1 cubed. All right, so the next thing that we want to look at is the fundamental theorem of algebra. So basically what this states is that a polynomial of degree n has n complex roots. So if you guys don't know what complex numbers are, they're basically just anything that can be written in the form a plus bi, where I is equal to the square root of -1. But don't worry about that too much right now. Let's just focus on the fact that it has n roots. And this could include roots that occur more than once. So for example, in this case, the degree would be 3 because if you multiply the x term here, it would occur 3 times. However, the only root, or the only different root, the only root that appears is x equals 1. So we would say that when we say the fundamental theorem of algebra, that the polynomial of degree n has n complex roots, it would include roots that have a certain multiplicity. So if a root is counted more than once, each time it's counted would be counted as a root. So that's basically what the fundamental theorem of algebra is, and this allows us to this gives us a new piece of information. So all polynomials, let's just go back to p of x, right? So this p of x over here. All polynomials including this one, can be written as an times x minus r1 to x minus rn. So this is the factored form of a polynomial, and the reason we can write this is because if we look at it like this, right? For every okay, so these numbers, or these r's, they represent the roots. So these are the n roots of a polynomial of degree n. So if we substitute any root into this form, let's say we substitute r1, right? Then this entire thing will be equal to 0, and the whole thing will be equal to 0. So that means all of these r1s all the way to rn, they are roots of this polynomial because they satisfy that p of this r will be equal to 0. And then also we have the leading coefficient here, a to the an, because it doesn't affect the roots, right? It just multiplies the variable with the highest degree, so that the leading coefficient is equal to an and not just 1. So that's the fundamental theorem of algebra and how it can be applied to polynomials. So okay, I guess one last thing that we can cover is the quadratic formula. So basically, a quadratic is a polynomial with degree 2. So they're going to be written in this form, where a, b, and c can be any number. So in order to, there's actually a very simple way to find the roots of a quadratic, because there are only 2, right? So what we can do is, I'll just show the formula. So x is going to be equal to negative b plus minus the square root of b squared minus 4ac over 2a. So notice how there's a plus minus here, right? And this just means that there are two roots for this polynomial with degree 2. Because since it has degree 2 by the fundamental theorem of algebra, we know that there are going to be 2 roots. And this plus minus yields us 2 solutions to x. Yeah, so that's pretty much all we're going to be covering in this lesson today. Thank you for listening.